Hello, welcome back to Digital Urim. Up to this point in the course, we have built something extremely important. You learned how security works, how attackers think, how incidents are detected and handled, and how sensitive data must be protected. But now, we are entering a new phase, a more technical phase, a deeper phase, a phase where we move beyond concepts and begin to understand how systems truly work. Today, we begin Block 2, Operating Systems. And this moment represents an important transition, because from this point forward, you will begin thinking like a technical professional. Many people believe that an operating system is simply what they see on the screen: Windows, Linux, Mac OS. But that understanding is incomplete. The graphical interface is only the surface. Beneath that surface, there is a complex system that controls everything. An operating system is the central manager of hardware and software resources. It constantly makes decisions. It decides which program runs, when it runs, how much memory it uses, and which resources each program is allowed to access. Without an operating system, a computer cannot function properly. It would simply be hardware without coordination. Imagine an orchestra. You have talented musicians, high-quality instruments. But without a conductor, the result would be chaos. Each musician would play at different times, different speeds. Without coordination, the operating system is that conductor. It coordinates every component, maintains order, prevents conflict. Without it, the system becomes unstable. And from a security perspective, it becomes vulnerable. Now let's go deeper. An operating system controls several critical components. Each one plays a major role in cybersecurity. CPU, the execution engine. The CPU executes instructions, but it does not decide what instructions to execute. The operating system makes that decision. When you open multiple applications, the operating system decides which one runs first, which one waits, which one receives more processing time. Attackers sometimes abuse this behavior. For example, malware can consume excessive CPU resources to slow down systems. This type of behavior can resemble a local denial of service condition, and it happens inside the operating system. Memory stores programs while they are running. Every active program requires memory. The operating system manages which program uses memory, how memory is allocated, when memory is released. Here is something important. Many modern attacks do not rely only on files. Some attacks operate directly in memory. These are called memory-based attacks. They are harder to detect because nothing obvious appears on disk. And again, this activity occurs inside the operating system. Every running program is called a process. The operating system controls how many processes exist, what they do, and how they interact. Here is a realistic example. Malware rarely announces itself. Instead, it runs quietly as a process. It may even look legitimate, but its behavior can reveal malicious intent. Detecting unusual processes is a core skill for cybersecurity analysts. Operating systems manage files. They allow systems to read data, write data, modify data, delete data. Attackers use files to store malicious code, but they also use files to maintain persistence. For example, a malicious file configured to run every time the system starts. This technique is called persistence, and persistence is one of the most dangerous behaviors in modern attacks. Here is something critical. Most attacks do not happen on the screen. They happen inside the operating system. Consider this example. A user downloads a suspicious file. They open it. The file executes. It becomes a process. It accesses memory. It modifies files. It connects to the internet. All of this activity happens inside the operating system. That is why we say, the operating system is the real battlefield. Imagine a corporate environment. An employee receives a file. They open it. That file contains malware. The malware executes as a process, hides itself, connects to an external server, downloads additional tools, and begins stealing information. Nothing visible appears unusual at first, but inside the operating system, everything has changed. This is why understanding operating systems is not optional. It is essential. Now we introduce something that will become central to your professional journey: Linux. In professional cybersecurity environments, Linux dominates. Most internet servers run Linux. Most cloud environments run Linux. Many cybersecurity tools are built specifically for Linux systems. But here is the key point. Learning Linux is not about memorizing commands. It is about understanding behavior, understanding structure, understanding logic. It is about learning how the system thinks. And once you understand that, your entire perspective on cybersecurity changes. In Linux systems, there is a powerful concept called privileges. Not all users have the same level of access. A normal user has limited permissions, but there is a special user, root. The root user has complete control. Root can modify system files, install software, change configurations, delete critical components. That means if an attacker gains root access, the system is fully compromised. This situation is called privilege escalation, and it is one of the most common attack objectives in real-world systems. Today, you learn something fundamental. An operating system is not just an interface. It is the heart of the system. It controls resources. It coordinates activity. And it is where attacks occur. You also began developing a Linux mindset, because understanding Linux will be critical for everything that follows. In the next video, you will go deeper. Video 2.1.2 you will learn what the kernel is, what user space means, how system calls work, how programs communicate with the operating system. Because once you understand what happens inside the system, you will never look at cybersecurity the same way again. Understand, defend, grow.